Hello everyone, my name is Jahnavi and I am from National Institute of Technology, Andhra Pradesh. Today I am going to discuss about bisection method and algorithm using Matlab. So let me introduce what is bisection method. Bisection method can be used to find roots of nonlinear equations where the function is continuous. Roots can be found for nonlinear equations which contains two or more higher order polynomial equations or exponential, logarithmic, trigonometric, etc. For example, I have taken here two equations which are nonlinear equations. Nonlinear expressions f of x equals to 0 is defined like this. Similarly, more than one variable is defined as in the expressions f of x1, x2, x3 so on is equals to 0. This method helps to achieve the exact solution when all parameters are correctly reconstructed. But the biggest drawback of this method is slow convergence. First step of bisection method for solving any equations in determining a range a comma b. The steps are repeated again, divided into two parts of the root. The important point in here is it can be used only when the function is unimodal in the taken range. So here algorithm is given to find the root of a function f of x equals to 0 in the range of a comma b, where a comma b are initial values for one variable and continuous function f of x. If f of a dot f of b is less than 0, like f of a is getting multiplied with f of b, and if it is should be less than 0, the function is crossing the x-axis and hence the point of intersection become the roots. Else if f of a multiplied with f of b equals to 0, means f of a equals to 0 or f of b equals to 0, then the root is either a or b. Then we have one more condition, that is f of a into f of b is greater than 0. Then there is no range of a comma b because f of a and f of b has same signs. So there is no crossing the x-axis of function. So next, now consider the midpoint of the initial interval m equals to a plus b by 2. Case 1. F of a is less than 0, f of b is greater than 0. If f of a into f of m means nothing but our interval value, and we'll put the interval value in the function. So f of a into f of m is less than 0. The root of the function is in the range of a comma m. Means we'll update the b equals to m. If f of a dot f of m is equals to 0, then the root will become our interval value. Else the root of the function is in the range of m comma b, means a equals to m. Same happens also with the other case, that is f of e is greater than 0 and f of b is less than 0. Our ultimate goal here is to take f of a and f of b in opposite signs. Now m is considered as a and this process repeated with the newly defined range. It will iterate the procedure. The process will repeat until the value of the function is either 0 or it reaches the minimum specific epsilon. Epsilon is nothing but the value of error, and it is expressed in terms of 10 power minus n, where n denotes the number of iterations required. So I'll take here an example. Let us take an example, that is f of x is equals to x log x minus 1.2. Here n is given as 4 and epsilon is equals to 5 into 10 power minus n minus 1, that is n equals to 4, so 10 power minus 5. So let us take assume a value. Initially I'll take x equals to 0, f of 0 is negative value, f of 1 is negative value, f of 2 is negative value, so f of 3 is positive value. Here we take the condition that f of a into f of b should be less than 0, so that a point will exist in the interval. So I'll take f of a as 2 and f of b as f of 3, and we got value as minus 0.138 less than 0. So condition is satisfied. Initial range we assumed as 2, 3. So after taking iterations 13, we'll iterate and we'll update the values of a and b according to the range we taken and which value we got in interval. So this is f of m. So I performed 13 iterations and I got these values. So this is the Matlab code. So I'll clear all things and I wrote function where function equals to at the rate of x. I wrote the x into log x minus 1.2 and I assumed a equals to 2, b equals to 3 and n equals to 6. Epsilon equals to, we got the maximum error and I given the maximum iterations. It's our wish to give any iterations, but it should be minimum this epsilon rate. It should beat the minimum epsilon rate and m equals to a plus b by 2, which compute the midpoint, and error equals to abs of f of m, compute the initial error, and we'll set the initial iteration counter and we'll for table I'll give these variables and for creating table I gave those equations and x equals to this. If f of a into f of b is greater than 0 means our condition is not satisfied here, so it will display wrong choice of a and b. Else while iterate less than or equals to iterate max and error is greater than or equals to epsilon, then it will perform if f of a into f of m is less than 0 means we have to update b equals to m, and if f of a into f of m is less than 0 and we'll get a equals to m, and it is nothing but intermediate mean value property. So we will end here and we'll compute the new root, means updated a and b values will be here and we'll compute mid value for that thing, and again we'll compute the error of the new root and we'll update the table. For every iteration we'll update the table and we'll increment the iteration counter and we'll plot the graph. This is the for printing purpose, like for table and for graph. So I got this as result. I got answer as root is 2.70060, and this is the table and this is the graph I got. See, you can see the function and the mid value, like the root of the function, that is 2.74065. If we perform practically, we'll get same answer. So bisection method is used in many areas, like there are many applications. Mainly it is used in fields of mathematics, engineering and science to find the roots of an equation. Here are some specific applications of bisection method. Solving algebraic equation. The bisection method can be used to find the roots of algebraic equations. This includes finding the roots of polynomial equations and other type of equations. Finding the roots of transcendental equation means like trigonometric, exponential, logarithmic functions, etc. Optimization problems, like to maximize or to minimize the function, we'll use the bisection method. In financial modeling, like to solve the equations related to interest rates, bond prices and other financial calculations. In physics we'll use like to solve related to motion, energy and other physical phenomena. I took application regarding solving Stein-Hart equation, means for what are thermistors means? Thermistors are temperature measuring equipments. Thermistor material shows a range in electrical resistance with a change in temperature. By measuring the resistance of thermistor, one can then establish the temperature. Here 10K3A beta therm thermistor. The relationship between R and temperature is given by this equation, which is non-linear equation, where T is in Kelvin and R is in ohms, like T is temperature and R is resistance. So here I took the equation and I solved it. The bisection method can be used to determine the temperature of thermistor, which is a type of resistance that changes its resistance in response to changes in temperature. The resistance of thermistor can be modeled by Steinhardt equation, which relates the temperature to the resistance. T equals to A plus B log R plus C ln 3 R. Means here A, B values are given here in this equation. So here, to determine the temperature of thermistor using the bisection method, we can start with an interval T1 comma T2 that contains the unknown temperature. So we are finding the temperature of the function. We'll then measure the resistance R of the thermistor and calculate the corresponding value of f of t equals to 1 by t minus a minus b r by r of ln of r by r naught minus c ln of r by r naught power 3. If f of t1 and f of t2 have opposite signs, then by the intermediate value theorem, then there must be a root of f of t in the interval t1 comma t2. We can then bisect the interval and repeat the process until the interval becomes sufficiently small, at which point the midpoint of the interval can be taken as the approximation of the temperature. So here I wrote the code. These are the temperature thermistor parameters. These are the coefficients of that equations A, B, C, and temperature, like we'll assume 18.99, and this is to convert into the Kelvin, centigrade into the Kelvins. So initial range resistance I took as R lower 11,000 or R upper 14,000, upper bound and lower bound. So to iterate the in table, like I wrote this line, and the function I wrote, and the tolerance level means a eta, like error. Maximum number of iterations it can perform, I given as 10, and bit value RL plus RU by 2, and error, and it will generate it as a table. So bisection method means, like in example we discussed as same here, I wrote those all things. If f of mid is greater than 0, then we'll update and all the stuff we'll do here, and we'll iterate everything here, and we'll find for every iteration we'll find a error, and we'll compare with the previous error. So here it is to display the result, and to plot the function I wrote this code. To plot the function like in graphical representation I wrote this code. The result here I got is in like this, like iterations. This is a values, this is b values, this is at the mid values, and this is f of m, and this is errors, and this is the graph I got. Like I got range between, the root of the function is 13,077.1. So this is the references I took over here, and this is all over about bisection method. That's it. Thank you.